Hello and welcome to 5-Minute Math. Today we are looking at the 5th grade concept of generating additive and multiplicative patterns. This is standard 5.4C in the great state of Texas, and we are using item number 24 off the 2017 released STAAR test. If you have not done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we have 4 different tables. All we need to do is find one that represents this right here, y equals 3x. Now this x is a variable, it is not multiplied. So one thing we need to realize is that when you see a letter and a number right next to each other and there's no operation that is signaled, you're going to see that quite often that is going to be multiplied. So as you get older in school, they're just going to drop the multiplication symbol, because the x sometimes looks like a variable, the dot can sometimes look like a decimal, and so they'll just put a number next to a parentheses, that means multiply, a number next to a letter, that means multiply. So we are looking at a multiplicative pattern. So we're going to use substitution. So we're going to just simply use our equation, y equals 3x, and we're going to substitute some of our x's. And so we're going to first let x equal this first x right here. We're going to start with f and just move our way across. And so we are going to substitute this x into this 3 right here. Now, in order to make it look like it still has multiplication, I'm going to use parentheses here. If I didn't use parentheses, it would just look like 33. So we don't want it to look like 33. We want it to be a multiplicative relationship. I could do a 3.3 or 3 with an x, but really we're kind of beyond that. So I'm just going to put a 3, parentheses 3, and this means multiply. And that's kind of a strange thing in 5th grade, but we do kind of drop the multiplication symbol, and it's just implied. We keep the other symbols. We keep addition, subtraction, and division. We just kind of drop multiplication because we do so much of it. So y equals 3 times 3, so y equals 9. Nope. You know what this looks like? This looks like they divided by 3 rather than multiplying by 3. So F is incorrect. Let's move down to J. We're going to say y equals 3x. We are going to substitute. In this case, x is going to equal 1. Let's always start with that first one. So 3 times 1. And then we'll say y equals 3. Okay, so that checks out. You know what, before we keep going down there, let's see what happens with the first row of h and j, because that might prove to be, pretty simple here. Y equals 3x. We're going to let x equal 1 right there, so y equals 3 times 1, and y equal 3. No, definitely not. They didn't even do anything. They just multiplied x by 1 is really what they did. They kept everything the same. So let's go down to j. Y equals 3x. So y equals, my x is still going to equal 1 here. 3 times 1. So y equals 3. Aha, so look at that. I've got g and j. Looking good so far. So let's take my second row of g right here. Let's use this y equals 3x. Y equals 3 times x is going to equal 3 at this point. 3 times 3. So y equals 9. Still looking good. Let's see what happens with j. I'm going to move that right over here. Y equals 3x. In this case, we're going to let x equal this second row of 4. Y equals 3 times 4. Nope. Y equals 12. You know what it looks like they did? They just added. This was like a plus 2. This looks like it's a plus 5. I'm not even sure what that pattern is. It's not really a pattern. So it looks like, let's see, we could just kind of shortcut it there and say 1 times 3. Yep. 3 times 3. Yep. Let's check 4 and 7 times 3. Looking good. Yep. My answer is G.